Hello guys, today we'll be reviewing topic E.1, the first topic in in chapter E, the final topic in the IB physics syllabus, which is nuclear and quantum physics. Topic E.1 talks about the structure of the atom. So we all know the structure of an atom. It is simply a nucleus with protons and neutrons in it. Let's say one proton, simplify for hydrogen, followed by energy levels or rings that have electrons on them. Okay, so this is for a hydrogen atom, you'd have one proton and one electron, and you keep on adding. The more protons and electrons, the more energy levels, and the heavier the atom. So, what significance does this have? Well, in the early 1900s, yes, scientists began experimenting with the atom, and they found out something very important, that the atom's radius, the nuclear radius, which is this, so here from here, the nuclear radius is directly proportional to the number of protons and neutrons, or what we could like to call the mass number, by the following equation. The radius R is directly equals to R node, which I'll tell you about, multiplied by e to the 1/3. So, first, this is the nuclear radius. Do not confuse it with the atomic radius, because the atomic radius is much larger, about 1000 times larger. And this is known as Fermi, or Fermi's radius. It is a constant value, which is 1.2 times 10 to the negative 15 meters, or 1.2, I forgot, but I think micrometers. Yes, it's 1.2 times 10 to the negative 15 femtometers, yes. Okay, and A here is the mass number, which you are supposed to know is the number of protons plus the number of neutrons. It is a larger number on a periodic table for each atom. And this equation states that R, the radius of any given atom, is equal to R node, which we also simplify to the cubic root of A. So for hydrogen, it would simply be the Fermi radius, since the cubic root of 1 is 1, so R equals R node. For helium, it would be the cubic root of 4 multiplied by R node, and you keep on continuing. But if you have not realized, what's more important here is that actually, from this equation, scientists were able to find out that all elements have the exact same nuclear density. So the density of all nuclei is exactly the same, not one, or approximately the same. You could say approximately. How? Well, I'll show you. So what is density? Rho here is equal to mass divided by volume. Okay. Mass here of an atom, we could simply, of a nucleus here we're talking, we could simply transform it into what the mass of the separate mass of protons and neutrons. But since protons and neutrons actually have very similar masses, there's something known as the unified mass unit. Okay, so the mass of the nucleus is actually equal to the number of protons plus number of neutrons. So let's let the mass number equal x multiplied by u, the unified mass atomic unit. Or if you want to know u here, we use it actually to get the mass of one atom of any given, or one nucleus, since we actually neglect the mass of electrons, so it's basically the mass of one atom of any element. So hydrogen, which has one proton, would be U, Helium, which has 2 protons, 2 neutrons, would be 4U. Uranium, which has 235 protons and neutrons, would have 235U. Instead of separately adding the masses of protons and neutrons, we use this, and it is a approximate simplified model. And if you want to know what it actually is, U is actually equal to 1 over 12 the mass of carbon 12. Carbon 12 means carbon atom that has 12 protons or neutrons, or the mass number is 12. Okay, so let's get back to here. So we can simplify the mass of a nucleus equal to the number of protons and neutrons x, the mass number x, or we should call it A actually, since here is given as A, multiplied by the unified mass unit. And V here, where in the model we assume that all nuclei are spherical, so it just becomes 4 over 3 pi r cubed. Okay, let's get back here. And we could just take the 3 up, since mathematically it could be 3au equals 4 pi. And here's the important part. Well, we know that the radius here is given by r equals r node a to the 1 over 3. So let's just substitute it here. So r node a to the 1 over 3 cubed. Well, that would give 3au over 4 pi r node cubed, and a to the cubic root of a cubed is a. So a is cancelled out. Density becomes 3u over 4 pi r node cubed. What you see here is that density is made up of constants. U is a constant value equal to 9.11 times, oh, that's a massive electron, sorry. It's approximately equal, and it's also in your data booklet as U is equal to 1.661 times 10 to the negative 27 kilograms. And R node, as I stated, is 1.2 times 10 to the negative 15. That would be actually meters. And this is pi, of course. We all know 3.14 and continuous. And 3 and 4 are of course constants. So we have proven that the density of all nuclei is actually equal to this value right here, 3u over 4 pi r node cubed. Okay, so another thing found about the atom is its interaction with the electromagnetic waves. You could have heard this before, that when an atom, especially if you're taking chemistry, if an atom absorbs a photon, or let's say a wave, I don't want to confuse you, we'll talk about photons later, light of wavelength x, it will emit that same wave. So basically when it absorbs it, the atom here, let's say this is a nucleus and this is an electron and these are energy levels. When it absorbs the wavelength, it jumps up to here. Then when it emits the wavelength, it jumps down back to its ground state, its original state, which we call its ground state, okay? And it emits the exact wavelength that it has absorbed. So here, scientists hypothesize that electrons, or atoms in general, are made of discrete energy levels. What does that mean? That means that each one of these circles have a specific energy that doesn't change, okay? So this, we call it the ground energy level. For example, has an energy of 1 electron volt. This has 5 electron volts. This has 7 electron volts, and will never change, okay? So if a wavelength or a wave of energy 6.99999 electron volts comes to the atom will not absorb it, since it is not equal to the difference between any two energy levels, okay? Okay, so here for an hydrogen atom, since it has there are no other electrons to interact, so it's easier to explain. The energy between two given energy levels or of a energy level of a given energy level is equal to negative 13.6 divided by n squared electron volts. What is an electron volt first? An electron volt is the unit we use here since we're talking about very, very small energies. The electron volt is simply one, or I'll tell you, okay. So we know energy here is actually equal to charge multiplied by potential difference or voltage. So if you see here, the unit of charge of one electron is E, so it becomes EV, okay? And E, in order to convert from EV to joules, so 1 joule equals 1.6 times 10 to the negative 19 multiplied by the value of E in EV, okay? So, so 13.6 is a constant value, so it is basically inversely proportional uh, to to the energy level squared. Okay, so given any energy level, any two energy levels. So, for example, you want to find the difference between energy level 1 and energy level 3. Okay, so you would calculate their energies and minus the difference, and now you'd know what wavelength or what energy is required for an electron to transition between these two energy levels. Okay, and the final equation uh, in this topic is known as the quantization of angular momentum. Okay, well, electrons orbit around the nucleus. Okay, they actually orbit at a constant speed or a constant rate. They orbit at a constant momentum. All of them have angular momentum. They have angular speed since they're rotating in circular paths, or we assume that they have constant angular momentum. Okay, so the angular momentum of actually any given, or we assume, of course, any given electron in an energy level is given by the following equation: mvr, which is actually equal to L, which is angular momentum, equals to nh over 2 pi. Okay, so we see that h, now if you don't know, is Planck's constant. It's the most famous constant in quantum physics, or in this topic actually. You'll find it a lot in many equations. It's very recurring. And n, of course, shows the energy level of the electron. And we could also simplify that L is equal to nh, like this. So what this value of h? Well, this is simply h over 2 pi, which we also call the reduced Planck constant, which has the value of h divided by 2 pi, because if it comes up in your exam like this, don't get scared. So basically, we're saying that L, the angular momentum, is directly proportional to the energy level of the electron. So let's solve some questions here. Okay, the diameter of a nucleus of a particular nuclide is 12 centimeters. So its radius is basically 6 times 10 to the negative 15. Okay. What is the nucleon number? The nucleon number is A. So we know that R equals R node A to the 1 over 3. So I want to find A. Well, A is basically this R over R node cubed, which is equal to, well, since we know that these are both order of negative 15, we can simply state that is 6 over 1.2 cubed, which will equal, and it has to equal a number, an integer number, of course, because the mass number cannot be in half, or very close, of course, since this is an approximation. Cubed equals 125, which is the correct answer. Okay. Okay, I'll write this down for you. It's a very important question to know. that the wavelength and energy are inversely proportional. Okay, so I'm drawing lines here, and let's assume here. So it's giving you lines like this, like this, and like this, and like this. So it's asking you the question, which one of these energy transitions emits the wavelength uh, of the longest wavelength? Well, since we know that energy levels converge at higher energies, become closer, so you would actually, of course, you would exclude this one, so this is incorrect, and it's between this one and this one. But we know that the energy levels between E2 or n equals 2 to n equals 1 will be much higher than that from n equals 3 to n equals 2. Okay? Since they converge at higher, I mean by converge, they get closer. So this would be higher than this, so this is incorrect, and the answer would be this one. It emits the lowest energy and thus the longest wavelength. Okay, when an electron in an atom transitions from a higher energy level to a lower energy level, which of the following occurs? A photon is absorbed, a photon is emitted, the atom becomes ionized, the electron is ejected from the atom. Well, we know that C and D are obviously incorrect. Ionization is not even our topic. And the electron ejected is also ionization, but they're just using different words. So it's between a photon is absorbed or emitted. Well, I told you, when an atom is absorbed, when a photon is absorbed, the electron moves from lower to higher energy levels. So when an atom is when when an electron moves from a higher energy level to a lower energy level, a photon must be emitted. So the answer would be B. What does the notation carbon 14 6 represent? A carbon atom with a massive number of 6 and 14 neutrons, a carbon atom with 6 protons and a mass number of 14, which is the correct answer, of course, since the mass number is this one right here, and this is the number of protons, so it is correct. Okay, and you consider a neutral atom of an element which has 18 protons, so element X has 18 protons and 22 neutrons, so we add them together, it gives us 40. So describe the structure of the atom. Well, it's simply telling us to tell them the number of the three fundamental particles in our syllabus, of course. So it has 18 protons, 22 neutrons, and 18 electrons. Since it's neutral, if it tells you it has, for example, a charge of -1, well, that would mean that there is one more electron than the number of protons, so it would have 19 electrons rather than 18. Define the relationship between the radius of a nucleus and its Euclidean number. Well, basically, the relationship is that the radius of a nucleus is directly proportional to the cubic root of the Euclidean number, or the mass number, we also like to call it. And the constant here, we could also say that the constant of proportionality is R node, which is Fermi's radius, and you tell them the value, which is 1.2 times 10 to the negative 15 meters. Okay, which describes a feature of the Rutherford model of the atom. Electrons occupy fixed orbits with quantized energy levels. That's incorrect. Which is correct here, but it's talking about the model, which is an old model. Most of the atom's mass is concentrated in a small central nucleus. Well, that would be correct, because in the alpha scattering experiment, they shoot alpha particles at a nucleus, and alpha particles with higher energy levels were able to get so close to the nucleus, so they were able actually to approximate, or they were able to tell that the nucleus consisted of something that is charged. Since these alpha particles were repelled, so they were able to state that the nucleus actually is heavy, since some atoms move through the atom, yes, without deflection, they came up with two important things, which that number one, that most of an atom is consists of an empty space, but in the middle of an atom there lies a small positively charged nucleus that is very dense and consists of most of the mass of the nucleus of the atom. Sorry, that's not here. An electron is in a hydrogen atom transitions from n equals 3 to n equals 2 energy level. Which of the following statements is true about the photon emitted? The photon has a frequency directly proportional to the energy difference between levels, which is actually correct, as I told you, that uh, that the energy of a photon emitted is equal to the energy difference between two energy levels. And since frequency is directly proportional to energy, we can also say that frequency is equal to or directly proportional to the difference in energy of energy levels. Three possible features of an atomic model are orbital radius, quantized energy, and quantized angular momentum. Which of these are features of the Bohr model? Well, if you're focusing through the video, if you write down the three equations, R equals R naught e to the 1 over 3, well, that's orbital radius, correct? And the second equation, E equals negative 13.6 over n squared EV. Well, that's quantized energy, since n is an integer. So all energy levels have specific energies. And the final one, quantized angular momentum, L equals nh over 2 pi, or nh bar. So it will be D, which is 1, 2, and 3. So today, guys, we reviewed topic E.1, the structure of an atom, which is mostly an HL topic, and all the equations I stated were actually HL. So I encourage you to solve some questions, and thank you.